This is the video for lesson 6.4. Please take the time to write in the learning target. I can use the side, side, side and side, angle, side similarity theorems. So these are the two theorems that we're going to focus on in this lesson. Basically what we're doing is we're going to use the same idea of scale factor. To prove that two triangles are similar. So the side, side, side similarity theorem says if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So if we can prove that every single side of one triangle has the same scale factor as every single side of the other triangle, then the two triangles are similar. Remember, similarity doesn't mean congruent, it just means that they have the same shape. So similarity means same shape, not same size. Okay, and then we have our next theorem, which is the side angle side similarity theorem. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional. Remember, proportional means they have the same scale factor. Then the triangles are similar. So we're going to practice using both of these similarity theorems, and we already know one other similarity theorem, which is the angle-angle similarity theorem, that says if there are two angles in one triangle that are congruent to two angles of another triangle, then the two shapes are similar. So let's go ahead and take a look at example number 1. First of all, I need you to make a correction. This triangle name is not correct. It should be triangle XYZ. You can make that correction, please. So the question here is either triangle RST or triangle XYZ similar to triangle ABC? So we're going to use this as our standard. This is the one that we want to use, and we're saying, is it this triangle or is it this triangle that is similar to triangle ABC? Well, what we need to do is find out what the scale factor is for each of them and each of the sides, and then we can determine if one or the other is similar. So if I look here, I have a side length that is 3, a side length that is 4, and a side length that is 5. So if I look at triangle RST, I see a 3, a 4, and a 4. Well, the first triangle is not isosceles, and this triangle is isosceles, so pretty much we know that this one cannot be the one that it's similar to, since there are not two lengths in our ABC triangle that have the same measure. So just by default, it looks like I'm going to have to say that it's XYZ, but let's go ahead and prove why. The shortest side of this triangle is 6. The shortest side of our first triangle, ABC, is 3. So we want to line up shortest to shortest and then reduce. So it looks like 1/2 is the scale factor, but we have to do that for each side. So my longest side of triangle ABC is 5. My longest side of triangle XYZ is 10. So 5 over 10. Again, that shows me that I have a 1/2 scale factor. And then if I take the medium length side, 4 over 8, that also equals 1/2. So I can see that if all sides have the exact same scale factor, then those two triangles are congruent. So we'll have to say that triangle ABC is similar to triangle XYZ. And we've proven that by showing that each one of the sides has a scale factor that is the same. And like I said, the middle triangle was isosceles, so that didn't work out for us for that one. So when you're working on your own problems, what I would like you to remember is I want you to compare longest to longest and shortest to shortest, because it's asking you here which of these three triangles are similar. You're only going to find two that are similar, but you do need to write a similarity statement. And make sure that you show your work. Show me that there is the same scale factor for all of the sides. Okay, just as a reminder, I have written here, compare shortest side to shortest side, and then of course longest side to longest side. That should help you out when you're working on that practice problem. Okay, let's take a look at example number 2, where it asks us to find the value of x that makes these two triangles similar. So I'm finding that information right here. So what is it that we need to do to make sure that triangle ABC is similar to triangle DEF? So we can probably use the two sides that don't have any variables and use that to find our scale factor. So 18 over 27. Now the number 9 goes into both of those, so if I reduce that, I'm going to find that my scale factor is 2/3. So that's important to find that first. All right, and then I can start using this information to set up some proportions, and just remember, this looks like it needs to be distributed. The 2 needs to be distributed here. So this is actually going to be 2x plus 2 when I put it in my proportion. Now, which side is going to be corresponding to 2x plus 2? This side here is 15. So I'm going to use my scale factor, and I'm going to put my 2x plus 2 on the top because that came from the smaller triangle, just like this 2 did. Okay, and then the 15 comes from the larger triangle. And now I'm ready to cross multiply. So I'd like you to set it up so that you're not going to confuse yourself. You have a 3 times 2x plus 2 equals 2 times 15, and that's basically going to come out to 6x plus 6 equals 30. And if I subtract 6, I'm going to end up with 6x equals 24, and therefore divide by 6, x equals 4. Now I could spend the time to check and see that that would actually make a side length that would create a 2/3 scale factor, but I'm not going to do that to keep this video short. But if I do plug it in here, I'm going to end up with 33 as my scale factor here, or sorry, my side length, and then over here, if I plug it in, I'm going to end up with 4 plus 1 is 5 times 2, that would be a 10. So you can see 10 over 15 reduces to 2/3, 22 over 33 also reduces to 2/3. So just checking to see that x equals 4 is a good answer. Okay, for our last example, on the back of the page it says find the value of x that makes triangle PQR similar to triangle TUV. All right, so triangle PQR, we have a side, an angle, and a side, and then over here we see that there's a side, an angle, and a side. So we're using the side angle side similarity theorem. So if the angle that is between the two sides is congruent and the sides have a similar scale factor, then we know that these two triangles are similar. So we want to find the measure of x that would make that a similar scale factor for those two sides as we have for 24 over 30. So 24 and 30 are sides that are corresponding, so let's go ahead and reduce this. The number 6 goes into both of them. So our scale factor is going to be 4/5. And then we can set that equal to 20 over 3x plus 4, because those two sides, this side and this side, are corresponding, and we need to now cross multiply. So again, 4 times 3x plus 4 is how you want to do this, and then distribute that 4. All right, so we're going to have 12x plus 16 equals 100. Okay, the 5 times 20 is 100. So if I subtract 16, I'm going to end up with 12x equals 84. And when I divide by 12, x equals 7. So again, I could plug this back in. 3 times 7 plus 4 is 25. And then just check to see, does 20 over 25 reduce to 4/5. And if it does, then you know that you did your work correctly. Okay, so what you're going to do is you're going to practice a couple of problems on your own. I just want to point out that when we have vertical angles, then that means that we're going to be using the Sas Similarity Theorem here, because we have a couple of sides that are corresponding. I also want to point out that the short side should be aligned with the short side to find that scale factor. And then to find the value of x, down here, make sure that you distribute that 2. So this is going to end up being 2x plus 2, remember? And again, you want to find the short side to the short side, the long side to the long side. So it looks like we have these two sides that can help you find the scale factor for this problem. So make sure you show your work on these, and then if you do have any questions, you can ask in class. Thanks for watching.